Okay, carrying on with lines, but now we're interested in angles. So we know we've got a recipe. We've got a cos theta equals recipe for working out angles. Am I ready to start that recipe? No, I'm not. Remember, with cos theta, okay, before you can get started on this, we need two directions. So let's first of all find two column vectors that give me the directions that I want the angle between. Okay, so where am I getting my directions from? Well, obviously this is my starting point here. Now, what do these column vectors tell me? Well, remember, in R equals A plus lambda D, A and D have meanings. Lambda is just a parameter, okay? But but A tells me a position of a point on the line. Does that tell me its direction? No. Do I care about 137? No. Okay? Which part of the vector equation tells me the direction? Answer is this D. So this 2, 2, 1 is the direction of the first line. So 2, 2, 1 is all I care about this first line. Okay? And for the second line, this is a position on the line. Well, that's lovely, but I don't care. This is the direction of the line. I don't need the mu, but so notice that when we've got two lines, we tend to use two different letters for the parameters. But I don't care about the parameter. I just care about the direction, which is 3, 0, 1. So this feels maybe a bit strange because we're ignoring a lot of information. Okay, it's like two lines with y equals mx plus c, and I just care about their gradients because I want to show they're perpendicular or something. I've just taken the relevant information, which is the two direction vectors, and I've ignored everything else about these two lines. So that's possibly the hardest thing about the angle between two lines that people get wrong. They just forget that they need to start by finding two directions, and they don't need to worry about anything else. So I've now got my two directions. I can now use my cos theta recipe, which is A dot B over the magnitude of A times the magnitude of B. But I can go straight in with my two column vectors. So I need to do 2, 2, 1 dot 3, 0 minus 1 all over the magnitude of the first one times the magnitude of the second one. This is going to tell me cos theta. Okay, so the magnitude of the first one is 2 squared plus 2 squared plus 1 squared. Magnitude of the second one is 3 squared plus 0 squared plus 1 minus 1 squared, which is 1 squared. This feels an awful lot like a previous example, but I don't think it's quite the same. Similar, but not the same. 2 times 3, dot product, you multiply the x's, the y's and z's and add them up. So 2 times 3 is 6, plus we get the naught in the middle this time, and 1 times minus 1 is minus 1 over, this is the square root of 4 plus 4 plus 1 is 9, and this is the square root of 10. I've had that before, but not quite the same as this. Top simplifies to 5, the bottom simplifies to root 9, root 10. Okay, now this I can see is an acute angle, all right? It doesn't say it here, but just so you're prepared, sometimes you see the word acute before the angle, even when you get an obtuse answer here. And the reason, and what's going on there is if I've now got two lines, maybe they cross, maybe they don't even cross. But in the case where they do cross, it's easier to visualize. Okay, lines don't point in a particular direction along their length, so there isn't an arrow on each line. So given two lines, there are always two angles I could find. This one, which is the same as this one, or this one, which is the same as this one. But these two are not the same as each other. There's always an acute one and an obtuse one. So if it asks for the acute angle between the lines, okay, depending on whether you have good or bad luck, you may or may not get an acute angle out. I can see this time I am going to get an acute angle out because this is positive. But if this was a negative answer, it's going to lead to an obtuse angle, okay? If I find that obtuse angle, I can take it away from 180 degrees to get the acute one. Okay, so there's one more step to do at the end. If it asks for an acute angle, with only one C, if it asks for an acute angle, okay, then you do have to make sure the answer you give is acute, okay? You can only do that if you're doing angles between lines, not angles between vectors. Anyhow, none of that's happened. All I need to do is take this value of cos theta equals this, and inverse cos it. So there's my answer for the cos, which is 0.5270. I'm still in degree mode. So inverse cos of that answer gives me 58.2 degrees, which is the angle I need. And I'm